All right, let's talk about 3D printing, or as it's officially known, additive manufacturing. Now, when I say that, what's the first thing that pops into your head? Because I'm willing to bet, whatever you're picturing, it's just the tiniest tip of a massive, really complex iceberg. So let's dive in.
Yeah, this is probably it, right? Some kind of desktop machine, humming away on a desk, slowly building up a little plastic doodad, layer by tiny layer. And look, for a lot of us, this is 3D printing. It's the public face of the whole technology. But what we're going to see is that this is really just chapter one of a much, much bigger story.
Okay, so get this. That little desktop printer, it's just one of 7 standard official types of additive manufacturing. 7. So yeah, this whole world goes way, way deeper than just melting plastic. It's so much more powerful.
So, what are the other 6? And maybe more importantly, how are they being used to build critical parts for things like jet engines and custom medical implants? That's the real question we're digging into. We're going to go on a journey from this desktop machine we all know, all the way to the high-tech factory floor to see what's really going on.
Okay, to make sense of all this, it's actually pretty helpful to break it down. You can pretty much group all these different technologies into 3 main flavors, and it all comes down to the material they start with. Is it a solid, a liquid, or a powder? If you can get your head around these 3, you've basically unlocked the key to understanding the entire field.
So first up, the one we all recognize, material extrusion. You've probably heard it called FDM. The analogy here is perfect. It's basically a super precise robotic hot glue gun. It takes a solid plastic string or filament, melts it down, and just draws out the object, layer by layer.
All right, next up, we're moving from solid plastic to liquid resin. This category is called vat photopolymerization, and the way it works is you have a tank of this liquid goo, and a really precise light source, like a laser or a projector, zaps the liquid and hardens it just in the spots you want. The result? You can get parts with absolutely breathtaking detail. And for our third and final flavor, we get to powders. This is called powder bed fusion. Just imagine, a machine spreads out an incredibly thin layer of superfine powder. Could be polymer, could be metal. Then a high-powered energy source, usually a laser, comes in and melts and fuses those powder particles together. And let me tell you, this is where things get really industrial.
Okay, now look at this comparison. What's absolutely wild here is the cost range. You know, your standard filament printer can be a few $100 for a hobbyist, but the pro versions can get up to $400,000. But then you look at powder bed fusion. These are the big boys, the machines building actual metal parts for rockets and surgery. They start at 300 grand and can easily go north of 800,000. We're talking about a massive, massive jump in both what they can do and what they cost.
So, let's focus in on that crazy high end for a minute. Let's talk about powder bed fusion. This is the tech that is genuinely changing the game in manufacturing. It's what allows engineers to print real, functional, ready-to-use parts straight from a pile of metal powder. Seriously, this is where the magic happens.
All right, quick but important technical detail. You're going to hear 2 words thrown around a lot: sintering and melting. Here's the difference. Sintering kind of just heats the powder up enough to make the particles stick together, but it can leave behind tiny little holes or pores. Melting, on the other hand, fully liquefies the metal before it resolidifies. That creates a part that's 100% dense and way, way stronger. It's a key distinction, and it's why most of the really serious industrial metal machines actually use a full-on melting process, even if the brand name has the word sintering in it.
You know, this whole field is notorious for what people call acronym soup. SLM, DMLS, SLS, EBM. It can be super confusing. But here's the secret. A lot of these are just brand names from different companies for processes that are, well, pretty darn similar. The best way to think about it is powder bed fusion is the family name. All these acronyms are just different siblings in that same family, each with their own little quirks. So for all that money, what are you actually buying? Well, this pretty much sums up the trade-offs. With something like selective laser melting, you get absolutely phenomenal strength and mind-blowing accuracy. I mean, we're talking about features smaller than the width of a human hair. The catch? It's slow. The parts can't be all that big, and yeah, as we saw, the cost is sky high. Okay, so this tech is cool for sure, but so what? Why does any of this really matter? What can we do now that was impossible before? Let's get into some actual real-world examples, because this is where it gets exciting. And the stakes here are enormous. Just look at aerospace. The UK alone has poured 10 million euros into pushing this technology forward. That's not just pocket change, it's a huge bet, a massive vote of confidence that this technology is delivering real, game-changing results right now.
And this is where the applications just become mind-bending. Think about it. Custom-fit spinal implants designed from a scan of a patient's own body to be a perfect fit, or helicopter and aircraft parts that are way lighter but also stronger than the old ones, which saves fuel and makes them perform better. We're talking about making things that were literally impossible to manufacture before, or just so ridiculously expensive no one would bother.
Now, for the longest time, this kind of crazy, high-end metal printing was trapped. It was locked away in these super specialized labs with multi-million-dollar price tags. But that's starting to change. A whole new wave of tech is coming, and it's bringing the power of metal printing out of the lab and, believe it or not, right into the office. Just look at this number, $100,000. Now, don't get me wrong, that is still a ton of money. But a whole new generation of metal printers is coming out around this price point. And when you compare that to the $1 million+ machines we were just talking about, it's a completely different ballgame. It's making real metal printing accessible to so many more people and companies. So, how on earth do they do it for that price? Well, it's a really clever 3-step process. First, you have a printer, and it looks a lot like a regular desktop printer, and it prints the part using these rods made of metal powder, all held together with a waxy binder. That first part is called the green part. Then you take that green part and you put it in a wash to get rid of most of that waxy binder. And for the final step, it goes into a special furnace that burns off the rest of the binder and fuses all those metal particles together into a solid, dense part. It's genius, really. And here's why that is such a big deal. This quote from Desktop Metal, one of the pioneers of this stuff, really nails it. You can now develop a functional prototype with the exact same material you're going to use for mass production. That is a game changer. It totally closes the gap that used to exist between a prototype and the real thing. Okay, so we've covered how metal printing is getting cheaper and easier to get your hands on. But remember how we said the parts were kind of small? Well, what about the other direction? What about printing big? That's the next frontier, and it is just as exciting. This is where we start talking about stuff like direct energy deposition, or DED. Forget the powder bed. With DED, you have a nozzle that's spraying a fine mist of metal powder directly into a powerful laser beam. It melts on contact. Just try to picture that. A robotic arm basically painting in 3 dimensions with molten metal. This is the kind of tech that could build or repair huge parts, maybe even whole sections of a jet engine, completely breaking free of that little boxy printer.
So there you have it. We've gone from the little desktop toy that everyone thinks of all the way to industrial giants that are fusing titanium powder with lasers to create parts we once only dreamed of. This technology is truly fundamentally changing how we make, well, everything. It's been an incredible journey, and it really just leaves us with one big question. Now that we can print pretty much anything we can imagine, what on earth are we going to print next?